All right. Good evening, everyone, and happy Sunday to everyone. I'm sure you guys are doing well. In today's class, it's going to be more like a combination of both our classes. Uh, we would be starting with the complex number. Is going to be really, really key to you being able to solve several questions on it. Please, can you still hear me? Can somebody tell me if you can hear me clearly? Now, this was the first question. You were to express five minus 3i all raised to power 3 in the form a plus ib. All right. Now, this is more like the way you solve these things quadratically. You have a cubic equation here. Now, I understand that you can solve this in the normal, natural way you do solve it, but I want to give you something, and I'm hoping this will really help you, because in everything we do, I always love to look for the most quickest way to achieve the result. Now look at this expression generally. If you have, let's assume, just hold this a bit and let's try and use the quicker way. Of course, you can go on to expand this the way you do expand quadratic equation. And of course, you can have this as 5 minus 3i times 5 minus 3i square. And then go on and, do this. And, that's a whole lot of work. And I love to make things simple and neat. So let's see this general format of expanding cubic equation while dealing with complex number. So let's assume we have our z being equals to a plus bi, all right? So if we're going to find z cube is generally going to be equals to a raised to power 3 plus 3a raised to power 2 b times bi plus 3a, then bi square, then plus bi cube. And if you go on to collect the like and unlike terms here, you will be getting a more simpler version as a cube minus 3ab square, then plus 3a square. I'm sure you remember I gave you that of square. That was in, I think, the first class. This is I here. I gave you that of square. If you remember when I gave you that of square, how to find the square of a complex number without having to, if you remember, I said real, then, so you can go back to that, to the video, and then you check out how that was done. But this is that for the cubic side of things. So look at what we have here now. We can easily go on to apply this. And of course, this is for the real part. You can see right here, this is for the real part, this is for the imaginary part. So when you have something like this and you're trying to bring this into this form, of course, A here is the real part, B here is the imaginary part. So you want to fill in your, look at the equation z equals to a plus bi. That means in this case, now in this particular case, when z was equals to 5 minus 3i cubed, this implies that our a here is equals to 5 and our b is equals to minus 3, based on b being minus 3. You can see it. So you can fix this here, and can you fix that quickly? For those of you that are following, can you fix that quickly and tell me what you got? Fix in the values of a being 5 and b being minus 3. You can fix into any of the two, but of course this is the simpler part. So you can fix into this, where you have a cubed minus, this is the real part, this is the imaginary part. So imagine you have a question like this. You don't have to go on to be doing all the many expansions. You just apply this short method. All right. So go on to apply a as 5 here. What do you get? So what's going to be the your final equation? Is anybody there with the answer yet? This is a very certain way of getting your answers without much hassle. So whichever one you want to use is up to you. Anybody with an answer yet? Okay, I love that. I can see somebody with an answer. So you go on to fixing your a as 5. That will be 5 cubed minus 3. Okay, I love what I'm seeing. So if you're fixing 5 here as a, that will be 5 cubed minus 3, 5, and our b being minus 3 square. So this will give me the real part. So what does this give me? This is 125 minus 15 times 9. What is 15 times 9? Anybody with a calculator there? 15 times 9 should give you 135. So that is 125 minus 135. So obviously, I already know this is minus 10. So I know that the real part will be minus 10. Can you see how very easy I got my answer without having to stress much? So I know my real part already. So imagine you had this in an objective, a multiple question, multiple choice question, and you were told to just find the value of a. That's a very nice objective question where they give you this whole thing and they say, what is the value for a? So you don't have to go on and expand the whole thing before you are able to bring out a. Looking at what I have given you here, and I think everybody needs to have this in their notes, making sure this is known to you, it's a very great thing. So you don't have to sweat so much on solving. So if you do the same thing, of course, this is just the real part I just did to get minus 10. Go on to do for b being minus 3 now and a being 5. Put this into this imaginary part. I'm sure you're going to get a very sound result. So I'm sure at the end of that, you should get your values to be, your final answer should be minus 10 minus 198. Minus 198i. This is the final answer, minus 10 minus 198i. All right, that's this. You can see our a is minus 10 and our b is minus 198. All right, that's that about that. So let's solve the other question. There was this other question I gave you yesterday. And I'm trying to see how we can move very fast today, so that because your exam is coming, and the much questions you are exposed to, the better. That's what I would love to do. Now let's solve the other question I gave you yesterday, and that one had to do with something else, which I tried explaining yesterday. This was the question: you had to express this particular complex number plus square root of minus 2, and then you have 2 square root of 2 minus I. All right, so you were to express this in the form that you were giving, in the form a plus bi. All right, please be sure you're paying real attention, because these are questions that I'll be very interested in knowing if you can solve it or not. So looking at what we have right here, you are told to express this in that form. So ideally, what you want to do is to just bring the two brackets together. That means you want to expand and then go on to get your final answer. But you look at what we have here. Looking at what we have here, there is something here that I was trying to explain yesterday. We have square root of minus 2. So from what I explained yesterday, I'm sure you remember that I told you that square root of minus 2 is the same as square root of 2i. So you have to replace that with this. So that means what we want to do now is minus square root of 3 plus square root of 2i. And then you have 2 square root of 3 minus I. So this is what you want to have now, because you have been able to replace the square root of minus 2 with square root of 2i. That makes sense, but now the next thing you want to do is to expand this normally. That means you want to go on to say this multiplied by this. This multiplied by this, obviously, this will be minus times plus. So we'll be starting with minus square root of 3 times square root of 3. Square root of 3 times square root of 3 is 3. And then we have a 2 here. So this will be minus 6. That will be 2 times 3. All right. And then we have square root of 3 times high. And then there's a minus minus. So this turns to plus. So that will be plus square root of 3i. All right. Now we have this square root of 2 and square root of 3. When you do square root of 2 times square root of 3, that will be square root of 6. That will be 2 square root of 6i, because there's a 2 here and it's all plus. So this will be plus 2 square root of 6i. And then the last but not the least, we have square root of 2. We don't have a square root here, but there is a plus, there's a minus here. So we have a minus, and then this is I times I. I times I obviously is I squared. So when you have, okay, let's first of all write this as square root of 2i squared, so that we can then break it down from here. So when you see what we have here, you can go on to break this down, because we're now going to have minus, because I squared is obviously minus 1. I'm sure you remember that I squared is equals to minus 1. So this obviously will turn to a plus, because this will be, okay, let me just write this for everyone to see. Now, there's a minus here, but this is minus square root of 2. Okay, let me write this much properly. Then this will be minus 1, because I squared is minus 1. So the minus minus here will turn that to plus. Minus 6 plus square root of 3i plus 2 square root of 6i. This will be plus square root of 2. Now, don't forget, we have to express this in the form a plus bi. So what you want to do is to bring all the real parts You want to bring all the real parts into to a different side. So we want to have, this is real, this is real. These both don't have any imaginary aspects in them. These are the two that have the high. So we want to have -6 plus square root of 2. This will be seen as the real part. And then we have plus, this is, okay, let me just write this so you can, this is square root of I, of 3, square root of 3i plus 2 square root of 6. All right. Now, looking at what we have right here, we can obviously tell that we are about to be done with this. But when you see square root of 3 and square root of 6, I'm sure you understand that you can actually express square root of 6 as square root of 3 times square root of 2. So this square root of 3i. So you see the way I'm going to bring out my final answer now. So I have this right here. Don't forget there is an high here. I forgot to add that. There is an high here. There is an high here. So high is common to them both. But can you see something happening here? We have the square root of 3 has a common thing in both of them. So we can bring that out as square root of 3. And then we'll be left with 1 plus 2 square root of 2. And then we can bring out the high on this side. So what we have as our final answer will obviously be -6 plus square root of 2. So this is how you should present it finally. Now, many things you should pay attention to here. One thing you can see now is the ability for you. The first thing you were tested on here is the ability for you to convert your square root of -2 to square root of 2i. That was the first test there. Then after you were tested on the ability for you to open these brackets perfectly. And then the last but not the least is the ability for you to conform your answer in this form. Because if you got all this to this place and you are not able to bring it to this last answer, you would not be perfect because you were told to conform this to the form a plus bi. Peradventure, they wanted to drag you a bit further. You could be told to fix in the value for a somewhere. And if they asked you to find the value for a, all these right here will be the value of a. If they told you to find the value of b, all these right here, all this here will be the value of b. So this is a and this is b. So that's why you must learn how to conform them to the format that you were given. All right. So this is that was the solution to what I gave you yesterday. Now let's move very fast to something else, still on complex number. Let's talk about the modulus and conjugates of a complex number. Again, I explained to you the importance of, please ensure you are taking the best of the best notes and you are paying attention to how all these things are being solved. Please really ensure that. I really want everyone to follow along. That's the essence of the class. Now let's quickly talk about the modulus and conjugate of complex numbers. The modulus and conjugate, very, very important topic. You would see something we did in our first class, and you would see how we're going to be able to bring out the modulus. All right. So we are on modulus and conjugate of complex number. So let's talk about the modulus and the conjugate. Very simple and straightforward. We're not going to waste much time here. So if we have our complex number, which we have always used as a plus bi, I'm sure everyone in this class is very much familiar with the use of this as our complex number. Now we're going to define the modulus. Modulus is that thing in some cases we can call it absolute value. It's always that thing that converts a negative number to a non-negative real number. So anyway, the modulus of a complex number will be given as the square root of a square plus b square. That's simple. It's that simple. So we can go on to say the modulus, once you are told to find the modulus of a complex number, whatever the complex number is, this is what you just have to do. Whatever the value for A is, put a square to it. Whatever the value of B is, put the square to it and take the square root of the sum of both of them. That's modulus. Now let's talk about the conjugate. The conjugate, all right? We always denote the conjugate as more like you have a Z and with a line on top. So it's very important for you to understand the way the nomenclature, because some questions may decide to be silent on the terminology and they may go on to just give you the symbol. So if you see a complex number with a line on top, what they're asking you to find in that case is the conjugate. Now, how do you find a conjugate? If you remember, while dealing with sorts, we always find a conjugate by taking the negative part of the other side. So when we're dealing with sorts, we used to say that if we have square root of, we have 1 plus sort 2 now, for instance, we always say the conjugate of this will be 1 minus sort 2, right? So if the same thing goes here, if we have a plus bi as our complex number, the conjugate will be a minus bi. That's just it. There's nothing more to it than this. Now, but I want to stress on this. Please take note, because when you're dealing with aspects of this in mathematics, there are always tricky questions, and I want you to be very much aware of it. Look at what I did here. I changed the sign for the imaginary part. The sign for the real part remained. It was only the imaginary part that the sign got changed. So please, no matter how you were given, make sure all you are going to change is the sign of the imaginary part and nothing else. So don't change the sign of the real part, all right? Sometimes you may be tricked and they would bring the imaginary part to the left and the real part to the right. To really try to understand if you really understand what you're doing. So make sure that you are paying attention to the sign you are changing. It's always the imaginary part you change the sign. Now let's go further now. Remember when we were solving for multiplicative inverse, when we wanted to do division of two complex numbers, we were trying to do z1 over z2. And I remember I told you that the trick to solving this question, one of the reasons why you needed to understand multiplicative inverse, is that z1 over z2 will be z1 times 1 over z2. All right? And this means and implies that you will pick your z1, then you multiply it with the multiplicative inverse of z2. And I gave you a formula in that first class on multiplicative inverse. All right. Now let's go. Let me bring out that formula. This was, of course, another way of writing 1 over z2 would have been z2 raised to power minus 1. I explained this to you in that same class. Of course, this is the reason why you always need to be at the basic explanations. Now let's write that multiplicative inverse we wrote the other time. If we wanted to find the multiplicative inverse of z now, we would say this is 1 over z. All right, and the formula I gave you the last time was, if you remember, it was a over a squared plus b squared, and it was plus I, and then we have minus b over the same denominator, a squared plus b squared. I'm sure you remember this. Now, if you go on to try and find the LCM of this, this was the formula I gave you then. But if you go on to try and simplify this by finding the LCM, you will have the LCM. The LCM will obviously be a plus b squared, and this will be obviously a plus, or plus times minus will be minus ib. I'm sure you recognize that if you're trying to solve the LCM. Now look at what you have right here now. Can somebody see exactly what's going on here? Can you notice that what you have as the numerator is actually what we called the conjugate? Can you observe that? A minus high b, A minus high b. So obviously, the denominator while solving this multiplicative inverse is the conjugate. So we can write the conjugate over. Now, if you look at the denominator was actually the square of the modulus. Because if you go on to try and square this, look at what we fixed there as the modulus. Look at what we fixed there as the modulus. This was the modulus, right? If you go on to square this, you can see that this obviously, these two, we cancel these two, and the square of this will be a squared plus b squared. This means that we can easily write this denominator as the modulus square. Invariably, this means that our multiplicative inverse is the same thing as the conjugate over the square of the modulus. All right? So these are things you should always be very much aware of, so that you can always tackle any sort of question. So all these are very, very important, because they could always twist questions. For instance, imagine they gave you the conjugate, and they gave you, or they gave, let's say they gave you just, imagine they gave you two known and they wanted you to find the other unknown. Imagine they just gave you two known, they wanted you to find the other unknown. You know, many things that can stem from understanding this concept. So please always ensure that these things are at the back of your mind. Please ensure you're taking a good note also, because so that you will be able to always go back on all these things. Now, this is, let's try and put an application on all this. But before we put an application, let's quickly talk about some properties. Very, very important properties that you must know around all these things. All right. I'm sure you guys really understood what we're saying. It's very simple, and there's no so much big deal around it. So let's talk quickly about some properties around modulus and conjugate of complex numbers. So number one, you need to know that if two complex numbers exist, this will exist also. The modulus of the multiplication of two complex numbers, z1 and z2, will be equals to, please, this is very vital. These are the things that will help you to know how to tackle questions. So if they give you something like this, and they fixing the multiplication of two complex numbers into a modulus, you should understand that it's still the same thing as if you splitted it. This is very much okay. This very much works. So whatever you are giving, always ensure that you remember this. Number two, the same thing goes for the division. When you have z1 over z2, it's also the same thing if you splitted it. All right, these are very, very vital aspects of complex numbers. So number three, we have, of course, you know that for this second one I wrote, z2, the modulus of z2 must never be equal to 0. You know why already. If it was equal to 0, that means this whole thing will be undefined. So that's why that condition is set there. Now the next one is, look at this one, very, very interesting one. If you have z1 and z2 and a whole conjugate, these are things that gives you an edge in solving questions. If you have the conjugate of the multiplication of two complex numbers, the conjugate, that means you are multiplying two complex numbers together, z1 and z2, and you took the conjugate of their multiplication. Note for certain that it's going to be the same thing as if you had the conjugate of z1 multiplied by the conjugate of z2 separately. All right. Now, another one is if you had z1, this one is quite interesting also. Imagine you are doing for plus, or you are even doing for minus. So z1 plus or minus z2, whichever one. If you have the conjugate of whatever your result was, so imagine you added two complex numbers together and you now found the conjugate. You can go on to try all these things. I would love you to experiment on this. pick two complex numbers, add them together, find their conjugate. Your result must be the same thing as when you splitted the two complex numbers and found their conjugate and then added the result. That means you found the conjugate of Z1 first, found the conjugate of Z2, the result you got, you added them together. It will be the same thing. Of course, since we added minus there, so it's also going to be the same thing if you are dealing with minus. So these are very important properties you must note while dealing with complex numbers. And I think the last but not the least I'll be writing here is a very, very interesting one also. Look at if you have Z1 over Z2. Now imagine you did this and then went on to find the conjugate of your results. That means you have done Z1 over Z2, then you now went on to find the conjugate. It will be the same thing as if you first of all found the conjugate of Z1, then you went on to divide it by the conjugate of Z2. Very, very interesting property that you have to always note. This will give you the edge in solving questions. Of course, when you have divisions like this, you must always remember that in this case, modulus now, the conjugate of Z2 must never be equal to 0. Because if it was equal to 0, this whole thing will be undefined. So these are important properties of complex numbers based on their conjugate and their modulus. Now, I want you to do something for me quickly now. Go on quickly using what I just told you, the formula I told you, the formula I just defined for using conjugate and modulus. Go and find the multiplicative inverse of 2 minus 3i. Please do that very quickly. Find the multiplicative inverse of, let's call this Z now. Find the multiplicative inverse of 2 minus 3i. Do that in just 2 minutes based on the new approach I gave you, that's using conjugate and using modulus. Anybody okay? I think some people are shooting an answer already. What's the final answer I saw there? Okay, different people are getting different answers. I would love to get more responses. Please ensure you're taking good notes. Very, very important. 2 minus 3i was the question given. Okay, we're getting different answers. That's quite interesting. So 2 minus 3i. Let's say this was Z. What I'm interested in when I'm asking to find the multiplicative inverse is for you to go on to find, of course, you're looking at what I just explained, the conjugate over the modular square. So what is the conjugate? I don't know I don't think you can get an answer as square root of 10 or something. Look, if you look at what we have right here, first of all, let's try and find the modulus. What's the modulus of what we have here? Of course, the modulus will be we don't even have to find the modulus. Let's just find the modulus square, because the modulus square is equals to a square plus b square, if you remember. So what is our a here? Our a is 2. So that's 2 square plus what's our b? Minus 3. Minus 3 square. This will give me 4 plus what? 4 plus 9. And that's what? That's 13, right? So what is our conjugate? If you have z as this, our conjugate will obviously be, look at it, 2 plus, in this case now, plus 3i. That's what you just have to change the sign of whatever the imaginary part was. All right. So in trying to find the multiplicative inverse, very simply, I just have to go on to say my z, the multiplicative inverse of z will be equals to the modulus, that will be 2 plus 3i over the conjugate over the modular square over 13. And what you can do is to split this up, because that'll be very nice to do. Let's split this up and we'll be having 2 over 13 plus 3 over 13i. All right, that's simple. So, and if you loved, imagine this question was an open book, you could decide to use that formal formula or make use of this. So this is the real application of conjugate and modulus of complex number. Can you quickly help me to express this 5 plus square root of 2i over 1 minus square root of 2i? Can you express this in the form a plus bi? Can you do that very quickly? Can you express this in the form a plus bi? Conform this, all what you have here, conform it to a plus bi. Let's see how you fare with that. I'm sure you guys are taking yeah, I did not write the modulus because I was getting the modular square, not the modulus. All right. The equation, the expression for the multiplicative inverse said conjugate over modular square. So when I'm getting the modular square, I would automatically be cancelling out the square roots in such situation. All right. So please, can you quickly help me conform this to this form? So find a way to get this here. Let me see how you fare with that. Anybody with an answer yet? What's your final answer? Quickly, if you are here to give this video a thumbs up, please do that very quickly. We just have 25 thumbs up. I think we can get that to over 50. That would be very nice. All right. So what's your answer for the last thing we just saw? The question I just saw, I just gave you. So look at it. When we have 5 plus the square root of 2i over 1 minus the square root of 2i, and you're told to conform this to the form a plus bi. Of course, what you have to do, looking at this is a perfect example of why you would need to understand the concept of conjugate. Because if you look at what we have right here, we have a denominator that is not permitted in mathematics, where in both cases, actually it's having a complex number and it's also having a sort. So you have to find a way to rationalize this. And to rationalize this, what you have to do is to multiply this by the conjugate of the denominator. So you multiply by the conjugate of the denominator, that will be 1 plus square root of 2i, and you divide by 1 plus square root of 2i. As I told you in mathematics, what we just did right now is we actually just multiplied by 1, because this over this is still 1. But of course, we are using this method in order for us to be able to change the form, to expunge out the denominator. So that's the whole concept of rationalization in mathematics. So if you see what we have here, we can easily multiply these two together, and what we'll be getting is obviously 5 times 1, that will be 5. 5 times square root of 2i, that will be plus 5 square root of 2i. And then square root of 2i times 1, that will be plus square root of 2i. Then square root of 2 times square root of 2, that will be square root of 2 times square root of 2, that will be 2. So that will be plus 2. Then I times I, that will be I square. and I square equals to -1. Or let me just write that here for the sake of people that may not understand what we're doing yet. But square root of 2 times square root of 2 is 2. So, and then I times I is I squared. Let me leave it like that so that we can take it step by step. But what I would love to do would have been to have just used the same line to do everything. Look at what we have here. I don't need to waste much time on this. This is, if you can look at these two things, you can go on to do the same thing. It will still work. But okay, let me do the same thing so that we can keep up with everyone that may not be able to follow. I wanted to change this quickly to difference of 2 square. So I wanted to change this denominator to 1 minus square root of 2i all square. That's what I wanted to write here. But for the sake of people that may not understand what I'm doing, then from here I can easily go and do 1 square and then do the whole thing and get my answer. But let me just do it straight off from there. This will be 1 times 1. That'll be 1. 1 times square root of 2. That'll be plus square root of 2. Then minus square root of 2i times 1. That'll be minus square root of 2i. And then minus square root of 2 times plus square root of 2 will be minus square root of 2 times square root of 2. That will be 2. And then I square. All right. Now, what are we going to get at this junction? Let's try and now solve for all this our I. We need to find a way to remember that our I is equals to -1. So what we have now is 5 plus, now look at what we have here. This is both I and I. They are both like terms. So we can have, that's 5 square root of 2 plus 5 plus square root of 2. That will obviously give me 6 square root of 2. I'm sure you agree. This is 5 square root of 2. This is 1 square root of 2. And then we have I. So this will be 6 square root of 2i. And then this last one, this was going to be plus 2, but this is -1. So this is -1 times 2. That'll be -2. I'm sure you can relate to what I'm doing. This will be over. So what we have here, of course, look at what we have here. This and this will cancel out. And then we'll be left with 1 minus. In this case now, this is I square. This will turn to -1. Don't forget, I square is always -1. So this is -1 times -2. So that'll be 1 plus 2. All right. So this is how we solve gently. Looking at the like terms, so this is 5 minus 2. 5 minus 2 will give me my value of 3. And then we'll be left with plus 6 square root of 2i. And everything will be over what? Over 3. All right. Now we can move on by finding the factors common to both of the numerator, to the both values in the numerator, and that we can see 3 is common there. That'll be 3 into bracket. We'll be left with 1 plus 2 square root of 2i. Everything over 3. When you're done doing this, you obviously can notice that the 3 will cancel the 3. And then our final answer will obviously be 1 plus 2 square root of 2i. All right. How many of you got this value? How many was able to get this value finally? So this is how you prosecute questions around complex number. You would need to be very careful. Of course, imagine, for instance, imagine you don't know I squared being equals to -1. This would have been a major issue. So without wasting much time, I want to jump out of this place. I believe I've been able to I should believe I've been able to communicate on this. You know what we're going to do? I'm going to give you one question on this, but that will be the last thing we're going to do before I leave complex numbers. But I want to quickly explain something around the Argand plane. I want us to get on that. But I'll give you a question that you will solve to get yourself much familiar with. We have lots of questions to solve this night. I mean, in the second part of what we're doing, we have calculus we want to deal with. We want to deal with some parts of calculus today. And I really hope that will help some of you to have better understanding. So this is the question I want to give you before I get into the Lagrange plane. So you have to find the conjugate of what we have here. 3 minus 2i. And then we have 2 plus 3i. Everything over 1 plus 2i and 2 minus I. You have to find the conjugate of this. Find the conjugate. Please take that down because I'll be cleaning up the board. So you have to find the conjugate of that. All right. So take that question down. We'll be solving it much later if we have the time. I want to quickly talk about the Lagrange plane so that nobody is there being confused. It's so simple and I don't want anybody to find it difficult. So let's talk about the Lagrange plane quickly. Please take that question down. We'll come back to it if time permits us. We can run into, by the way, I have more questions for you, but because of time, we won't be able to stay on complex number. So we have some other interesting questions to solve, calculus and some other ones. So let's quickly talk about the Lagrange plane. So guys, the Lagrange plane is something I know anybody can actually do. It's very simple and very straightforward. So it's more like a graphical way of representing complex numbers. And you don't have to sweat over it because it's very, very straightforward. So you can easily understand it as long as you pay attention to the details, the basics around it. So when you have you all know your x and y axis, and when you're dealing with a Lagrange plane, it's more like you pushing your calculus on, your complex number on, it looks like calculus is, so imagine you wanted to represent z equals to 3 plus 4i. All right. So what you have to note is, you see, you already know that we have two different sides to things. So you see this imaginary part and this real part, they both will be used on two different planes. So the imaginary part will be seen on the vertical plane, while that of the real part will be seen on the will be seen on the horizontal plane. So let's just sketch this up very quickly. Say we have our plane like this. We want to go on to say, remember when we were doing, by the way, we're going to start with conic section. We were solving a question yesterday before the glitches happened. So we want to start with that question on conic section. But I'm sure you remember when we were doing all this. So we have our imaginary part, that's the B part. You know, if we had this as A plus BI. So in this case, the B is the imaginary part. That has to stay on the vertical place. So we're going 4 units. So let's take 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You know, it's obviously just a sketch. We're sketching this on a Lagrange plane. So when you have something like this, you want to go, this is the imaginary part. We say it's going to stay on the vertical axis. Of course, this is the vertical axis, while this is the horizontal axis. So this 4 here, you want to go 4 units up. But 4 units up and 3 units horizontal. So 4 units on the vertical, 3 units on the horizontal. So 3 units here, 1, 2, 3. Where does this all lead to? You can see this is where it leads to. And so you want to go on to pick this up. This is 4 units for the vertical, the imaginary side. This is 3 units for the horizontal side. So this is where they both meet. So you want to roll this up to the point of origin. And that will give you go on to label this as your Z being equals to whatever you have here. All right. Now, someone will ask me, what if I had minus 3 here? if I had minus 3 on my real part, then I will go to the left rather than going to the right, because the minus 3 will obviously be featured on the left side of the x-axis, while the positive 3 will be on the right side. So if this was minus 3, I would be using this place instead. So it will be coming from here. So imagine I wanted to find the conjugate of this. How is the conjugate of this going to look like? Of course, the conjugate will be z equals to 3 minus 4i. So look at how it's going to look like. That means this my minus 4 will not be obviously on the top side, because the top side is for the positive 4. This will be on the downside, which represents the negative side of things. So this will be minus 4 here. So I will go on to find, of course, 3 is still the same here. 3 is still the same. So it's still going to be this positive 3. So, but it's going to be the negative side. So if negative side of y, so this will be the conjugate. So this is how a complex number, this is a complex number, this is conjugate. You can see the way they are represented on this, what we call the Argand plane. So, and this point here, the distance from here to here is always going to be the modulus. So, sorry, I said, is it the modulus? Yes, the modulus. So the distance from here to here will always be whatever the value of the modulus is. Now, I really hope this was, maybe I should just tell you to, of course, you cannot show me, but let me just probably do one more example on this Argand plane so that you can at least get a clearer understanding. So let's just solve z equals to minus 5 plus 4i. So imagine you are told to represent this on an Argand plane. How do you do this, obviously? So the first thing you want to do is to plot your plane. You can do yours wherever you are, so that once I'm done with mine, you can check it out together and be sure that we're on the same side of things. So of course, I told you that the imaginary part is on the vertical side, and you can see it is plus 4, not minus 4. So it's going to be on the top side. So let's say this is 4, but you can see right here that the real part is negative, minus 5. So that will not be on this side. This is the positive side of your horizontal axis. What is the negative side? So you want to go, this is 5 now. You want to go 5. So you want to go on to trace this out here. So this is going to be the point where that is, and this will be your complex number. And this will always feature as the modulus of the complex number. The distance, the length of this is always going to be the modulus. That will be the square root of a square plus b square. All right. So this is basically what you need to understand around Argand plane. Of course, there could still be more to it, but I believe this is the basics. So let's try and solve that question I gave you, and let's be done with complex number. Of course, if there's any, I did not say this is the whole kind of questions that we can all see, but I believe with the basics you have known, you should be able to solve any kind of question that you see. And of course, I'm still open to, of course, we're still going to even solve, because we're going to use the past question this night. There's a question in the past question last year on complex number. We're going to try and solve that, so that you can see how to apply all the basics you have learned. So you have to find the conjugate of this, guys. I'm sure many of you have tried it out. So what did you get? What was your value when you found the conjugate of what we have right here? We are dealing with complex number right here. So what is the conjugate? What's the conjugate? What's the conjugate of what we have right here? What answers do you get? Are you yet to get it? So the very first thing you have to do, because when you see a question like this, okay, I'm seeing some answers there. How did you get that as the answer? Okay, some people, I think I saw a correct answer. So look at it. What you want to do first, they ask you to find the conjugate of this. You first need to take this and make it all simple because this is all complex. To make this all simple, you have to go on to multiply the two brackets together, both the numerator and both the denominator. So if you go on to multiply this together, I don't want to waste time because I believe we have done this before. This will be 3 times 2, this will be 6. And this will be plus 3 times 3, this will be 9i. Minus 2 times minus 2, that will be minus 4i. And then minus 2 times 3, it's supposed to be minus 6. All right. But because there's I times I, which is I squared, which we turn to minus 1, that will be minus 6 times minus 1. That will be plus 6. All right. This will be over. Then we have 2. 1 times 2 is 2. 1 times minus, this will be minus I. And this will be plus 2 times 2, this will be plus 4i. And then this will be 2 times this 2 times this should be minus 2i squared. But because we have I squared there, that will be minus 1. So this will end up being just 2. So what does this give you finally? This will be 6 plus 6. This will be 12. This will be 9 minus 4. That will be plus 5i. This will be over 2 plus 2. That will be 4. Minus I plus 4i, this will be minus 3i. Now we have a simple balanced equation. So you can now go on to find the conjugate of this, which will only be for you to just go on to solve for 4 plus 3i. So you have to go on again to have your multiplication being done. If you do this, you're going to get 12 times 4, that will be 48. 12 times 3, that will be minus 36. Sorry, we got plus 3 high here. This is minus I times minus, sorry, this is plus 3, so this is supposed to be minus. Sorry for that. So your conjugate here will be minus. So we have 12 times minus 3, that will be minus 36. So I believe at this point, everybody should be 5 times 4, that will be 20i. Everybody should be much more perfect. Then we have minus 15. In solving all this, it's supposed to be minus 15, but we'll have to turn to plus 15 because of the I square, I times I being I square. And then the one on beneath is the denominator is 4 plus 4, that will be 4 times 4 rather, that will be 16. And 4 times, that's minus 12i. Then this will be plus 12i. Then this will be minus, it's supposed to be minus 9i squared, but it will be plus 9. So this is what we have. And then this will be 48 plus 15. That will be what? 48 plus 15 is 63. And the other one we have there is minus 16. Minus 16i. And then this 2 cancels this. We have 16 plus 9, that will be 25. So what we're left with is 63 over 25. Minus 16 over 25i. How many of you left your answers as this? How many of you said this was your final answer? Well, this is not the final answer because this is just, don't forget, this is just the working of all these things. The final answer now is, because we're told to find a conjugate, is 63 over 25 plus 16 over 25i. If you look at what we just did now, what we just did initially was we went on to solve. So all these things we did, you know, when we first made this whole fraction more simpler by multiplying all the brackets. We got this. Now, when we saw this, we could not yet go on to find any conjugate because this is still irrational. We went on to rationalize by doing this. When we're done rationalizing, we got this final answer, which is still the same thing as this. So this was the answer to this. But the question said we should find a conjugate. So this is the conjugate right here. So if you hand up here, you will be wrong. This is the correct answer. So if this was going to be in an objective question, be sure to know that these two options will be present. These two options will be present. So if you go on to pick this, you'll be wrong. This is the conjugate. I told you already that when you are doing conjugate, you want to reverse the sign of the imaginary part. This plus you have here is based on the fact that you're dealing with conjugate. This is the correct answer, all right? This is the answer when you solve this. But the question said find a conjugate. Find a conjugate. So you are done. This was all the solving you solved initially. You've not yet found you were not finding a conjugate when you were doing all this. You were just solving. All right. So we're just solving all this. So we solved it, we got here, we had to rationalize, we got here. So this equation, this expression is same thing as this. We've not solved the conjugate at all here. Then we went on to, now after getting this final answer, we now went on to do the conjugate, which is what we have here. Conjugate is very easy. All you have to do while finding conjugate is for you to just reverse the sign. So in this case now, the sign of the imaginary part was minus. So you see, all we have to do is to turn it to plus. If this was plus, this would have turned to minus. It's just that simple. Does it make sense to everyone? If somebody still asking how we got plus, I think I just explained that. I'm hoping that was clear enough. So this is now let's start from the conic section we were solving yesterday. Quite interesting conic section. Please, I want to beg you from my heart, pay attention to this next question and every other question we want to solve. This next question is very, very key. I would not I would be very honest with you. It's something that you need to, I'm sure many of you understand conic section already, but this question gives you it's more like those questions you consider being technical, or many of you will call technical questions. But it's very simple, and you need to understand the basics of conic section for you to be able to solve it perfectly. Now, the question told you that the foci of an ellipse was given as 0 and plus or minus 2. We are told to find the equation of an ellipse. And this was the foci of that ellipse. The foci was given as 0 and plus or minus 2. And you were also told that the vertices is 0 plus or minus 3. Now, as I told you already, just take for instance that you don't know the basics of conic section. Of course, you understand how hard that will be for you to be able to solve this question. So the basics are very key. But since we understand, I'm sure everyone here understand the basics of conic sections, we can easily solve this. I'm sure I'm talking to guys that understand conic section very well. All right. Now, you need to understand the basis of foci and vertices. What is the basis of foci? Your foci is always starting from, I told you, don't forget, the center of every ellipse is given as HK. And also don't forget the general equation of an ellipse. General equation is given as x minus h squared over a squared. Is it plus or minus? It's actually plus. Hyperbola is minus. Those are the basics you must never forget. Over b squared is equals to what? 1. So this is the basic general equation. Now, I told you already that for you to understand a square, where a square or b square is, to be based on a square is actually the longer side. If you remember the whole theory around that, a square is always the longer side. And do you remember that when you're dealing with an ellipse, look at an ellipse for instance. You can have an ellipse like this. You can have an ellipse like this. Now, of course, you can see right here that the meaning of this type of ellipse infer that you had your vertex on, you had your longer side on the x-plane. So the equation I had here is a perfect example of this kind of ellipse. But if you had this type of ellipse, what would have happened would have been that you would have had x minus h squared over b squared plus y minus k squared over a square equals to 1. If you understand the whole basics around ellipses, this kind of ellipse, of course, you can see here that the longer side is obviously on the y plane. And I told you that a square is always the longer side. So in this case, let's say this was the center of the ellipse. That means from here to here was A, from here to here was A. All right. And this is where we will call the vertices. All right. This is the vertices, the coordinates of the vertices being here. You understand that part? Now, if you were dealing with this kind of ellipse, this means that your A was actually, this was the kind of situation where your A was on the X plane. This would have been your A, this would have been your A. From here to here will be your A. All right. And in that case, this would have been the vertices. So this would have been the vertex. Sorry that I'm being a bit fast. I'm trying to see how we can cover as much as we can. So if we're dealing with this, this is the vertices. Now, having this understanding now, you know the center of the circle of the ellipse, sorry, is h comma k. And now you also know, if you remember what I explained to you, that while solving for the foci, your foci is always along the longer side. Your foci is always along the longer side. So that means if you had your vertex like this and you have your ellipse like this, your foci is always within. Your foci will be somewhere here, somewhere within. And the distance from the center to the foci is actually what we call C. So from here to here is actually C. If this was the ellipse we're dealing with. The same goes for this other type of ellipse. If this was the type of ellipse you're dealing with, your foci is always lesser than the vertex. So this is where, around where your foci will be. It's always within the ellipse. So this would have been C from here to here. From this place to this place would have been C. From this place to this place would have been C. All right. That is all. Those are some of the basics we have established in all the classes we have had on conic sections. Now, look at what we have here now. We're now trying to find the equation of an ellipse. We're given the foci. We're given the vertices. Now, when you look at this already and you have the basics, the basic understanding of ellipses, you already understand that in this case now, the ellipse is actually along the y plane. I mean the longer side, because you can see that this is where the addition and subtraction is done at. Because I told you that when finding foci on that ellipse, we have the basics as the h comma k, but depending on wherever your ellipse was tending towards, that means whichever part was the longer side. If it was on the x plane, let's say this was the case, you would add and subtract a from here. And if this was the case, you will be adding and subtracting, sorry, not a, you had and so if this is it was the vertex, you will add and subtract a. This is for the foci. If it's for the foci, you will add and subtract C, not A. And don't forget, C is always given as what? That's another basics you must never forget. When dealing with ellipses, how do you find C? C is actually, C square is actually A square minus B square. Once you have issues with the basics, you would have issues in solving questions like this. You need to remember this. Now, your C is always the distance from the center up until the foci. And when I look at this the way this was given, I already know that I added my C to my y plane, because this is the x coordinate for the foci, this is the y coordinate for the foci. And you see that nothing was done here. I already know from what I see here that my center of this circle, of this ellipse rather, is actually 0, 0. And I already know that my C, because I already know already, looking at what I have here, that my center is actually 0, 0. And I also can see that my A, because don't forget, we get the vertex, don't look at, from here to here, I said was A. We get the vertex from our A. So, and if we have 0 plus or minus 3, that means in this case, my A here is 3. Because that means from the point of origin, I added and subtracted 3. Because the point of origin is always 0. So I added and subtracted 3. So this means that my A is actually 3 from my vertices. And you know, on your foci now, you added and subtracted C from this side. From what you can see, that means you added or subtracted C from this. You can see that. Whereas from your vertex, I can see already that I added and subtracted. Okay, let me just say HK as the fundamental, which I remember explaining to you also. I added and subtracted A. All right. This means that A is actually 3 and my C is actually 2. So from here, I can go on to find my B, which is also very important. So my C square, which is 2 square, will be equals to 3 square minus B square. That will be 4 equals to 9 minus B square. That means B square will be equals to 9 minus 4. That means B square is equals to 5. That means B is equals to square root of 5. So I've gotten my A, B, and C. A is 3, C is 2, B is square root of 5. Very, very fundamental to understanding the equation of an ellipse. All right. So now we have gotten our A, we've gotten our B, we've gotten our C. We don't actually really need the C for the equation. We only need our A and B. So that means I can go on now, remembering that this ellipse was that of this. So my final answer will be what? If you go on to push that your ABC into this one, you get the wrong answer, because this ellipse was actually having the longer side on the y plane. So the final answer for this ellipse will be, of course, my origin is, the center of origin here is 0. So H and K is 0. HK is 0, 0. So I'll be having x minus 0 square over my B is actually square root of 5. That'll be square root of 5 square. Square root of 5 square plus y minus 0 all square over my A square, that'll be 3 square, because my A is 3, equals to 1. And the final answer for the ellipse will be x minus 0 is actually x. That will be x squared over, this will be 5 plus y squared over 9 equals to 1. If you want to understand this better now, you can go on to, if I gave you this equation and I said, go and find the foci and vertices of this ellipse, you will see that you will get these two answers back, which tells you exactly that you're correct. Does it make good sense to you guys? This is why you need the basics. All right. How many of you really understood what I just solved? You were able to follow through on it. These are very important question. So this is the equation of the, again, one very important thing you need to note is that if you go on, I said it before, let me say it again. If you go on to use this first one, where you are making x the longer side, because don't forget, one of the basics of ellipses is that the a square is always on the basis of which side are the longer side. So if you fix a square under the x aspect, that means you are saying the x plane was the longer side of the ellipse. If you fix a square under the y plane, that means you are saying the y plane are the longer side. Looking at the question you were given this foci and this vertices rather. This tells you already that the foci was along the y plane, because this is the x coordinate 0. This is the y coordinate plus or minus 2. So this tells you already that the foci was moving along the y plane. And the foci is always on the longer axis. So your foci will not be on the shorter one. So this tells you already that the foci was along the y plane. Same thing goes for the vertices. It's along the y plane. The vertex is actually the topmost part of the ellipse. This is where your vertex is. So if they told you already that your vertex was having 0 as the x coordinate and plus or minus 3 as the y coordinate, that tells you already that this ellipse was along the y plane. So if you go on to now put the answer for a square under x, you will be wrong. That means if you go on to put 9 here and 5 here, you will be wrong. All right, that will not be marked for you if you do that. So let's run to the next one. Now you are going to do this one. I'm sure you, from all I've said, I'm sure you'll be able to solve this next one. This one is actually on circle. So I want to get good answers, please, because I'm sure you guys are following. So you have to find the equation of this circle that had the center. Look at the center. The center of the circle was given as minus 5, 4, and the radius was given as square root of 2. So can you quickly find the equation of this circle? I'm sure you people should not waste time on this. You guys know these ones very well. Can you find the equation of this circle very quickly? Can you find the equation of that circle very quickly? I want answers. Don't forget that I would love to see a very important, a very good note, and also you could be asked questions around any of all these questions we are solving. By the way, the link to all the previous classes will be sent, I believe, this night. So you can stay tuned for that, just in case you probably needed to check up on certain things that you missed out on. The link will be sent this night. So what was your answer for the center, for the circle? Now you understand the general form of your circle. You know, all these conic sections have their general equation. For the circle, you have it as this. All right. And I'm sure you remember what each of all these things mean. Your center actually has a coordinate of h, k. So this means invariably that our h here is minus 5 and our k here is 4. All right. And this r right here stands for the radius. And we're told that the radius is square root of 2. So you just have to fix all this here. You will have x minus 5, everything all square, plus y minus our k being 4. And then we have the square root of 2 all square. So this will be x plus 5 all square plus y minus 4 all square equals to 2. I believe that is the answer you got. How many of you got that answer? Somebody was still getting root 2. You cannot get root 2 as your answer. You have to get 2 because square root of 2 square, the square will actually cancel. This square will actually cancel out the square root. All right. So I have a question on trigonometry for you. You have to solve that one just in, let's say, 5 minutes. Trigonometry, let's try and solve that quickly. We'll get into calculus in a bit. So you have to solve the following. You have to solve this trigonometry equation. Now, I needed to ensure I stated this because always remember that when you have this given, you understand what it means. I remember teaching you angle of any magnitude. So this is vital. So when you're told to, you are given this expression, ensure that you use the understanding of angle of any magnitude. So this is the trigonometry equation you are told to solve. Your exam is coming soon. Please pay attention to every question we are solving. All right. Can you do this under 2 minutes? Can you give me the answer for this trigonometry equation? We have sine theta tan square theta, 2 sine theta plus 3, and we have plus tan square theta. Can you give the answer to this? What is the answer? Please ensure you're taking very good notes. Anybody with an answer yet? Okay, I'll give you just 30 seconds more and I will start solving. Okay, anybody with an answer yet? Okay, no, I'm actually here. I'm waiting for you to solve. Somebody's saying he could not hear anything. I'm actually waiting for you to solve. Okay, so let's try and solve this together without wasting time. Can you see what I can see? Look at, we have tan square theta here. Don't forget, this is a side of things. This is something plus something equals to 0. This is an equation. So this whole equation, this whole side of things and this whole side of things, one thing common to both of them is tan square theta. So we can factorize tan square theta out initially to have tan square theta. Then we can open this right here and we'll be left with sine theta, then 2 sine theta plus 3. All right. So we close, we have plus 1 because we have brought tan square theta out. This is perfect factorization. All right. We just factorized tan square theta out and we're having sine theta. And you show from this side, we're having sine theta and this. And then from this side, we're having 1 left equals to 0. All right. So the next thing you want to do is to open the bracket we have within, because this is the next thing you can do very much easily. So we have tan square theta. We have tan square theta. Then we are left with, this will be 2 sine square theta plus 3 sine theta plus 1. All right, equals to 0. Wow. Looks like some people are throwing some answers here. But I have seen one of the answers somebody wrote now, and I've seen something that is wrong there, and I'll tell you why. Of course, good try, but I'll tell you why the answer will not be correct. Just to give you the hint, go on to press tan 270. I can see 270 in your answer, and press tan 270 and see what happens there. Now, look at what we have here now. This, what we have inside this place, of course, you can see this looks so much like, this is a quadratic expression. All right. And this means we can easily solve that using quadratic means. So it's more like we had, let's try and just solve this within. Let's just solve this within very quickly. This is like 2 sine. Let's, okay. Just for the sake of people that probably just need to know this, I always like to balance the whole thing. I don't want to act like everybody understands what's going on. So let me just try and solve this for everyone. If you had something like this, what you have inside the brackets right here, you want to take, you can actually do without taking sine theta as x, but it makes much sense because I'm sure you guys are more familiar with the 2x squared and everything. So we have 2x squared plus 3x plus 1. So go on to solve this using your factorization. What are you going to get? You're going to get what? This will be 2x, and this will be what? You're looking for the sum of plus 3 and a product of 2. That's obviously 2x plus x plus 1x plus 1. Okay, so this will give me 2x into bracket x plus 1 plus 1 into bracket x plus 1. So I have 2x plus 1. This is common factorization I'm just doing, and x plus 1. All right, so I can go on now to fill my x back as sine theta. Then I will be having 2, because my x is sine theta, 2 sine theta plus 1 and sine theta plus 1. So if I just wrote this into this place, many of you would have felt, how did I get there? But all I wanted to do was to solve this quadratically. I used factorization method. I got this, and then I can now fill in this whole place to be this, which I believe is totally fine. So this is what I'll be doing next. I want to now, wherever all these things now, I'll be changing it to what I have gotten as my answer here, which I believe you all agree with. So we're almost close to the answers already. So I have coming from here now, I have tan square theta. Now I want to fill in this inside. So I have 2 sine theta plus 1, and I have sine theta plus 1. Everything equals to 0. So I'm sure you all agree now that we have this, all this is, all this is all multiplication. So this is all perfect multiplication. Who is Stella? I don't know. Stella said I should come back. What part does Stella not understand? Now, tan square theta times this times this. So I'm sure you all agree with me that it's very easy for me to now write. I'm not wrong if I do this now, because the meaning of this is that tan square theta is equals to 0. That's one side of things. Also, 2 sine theta plus 1 equals to 0. Also, sine theta plus 1 equals to 0. You can see what we have right here. So these are all from what we have here, because this is multiplication separating all of them. So that means this is equals to 0, this is equals to 0, and this is equals to 0. All right. So now let's start from the first aspect, which is tan square theta being equals to 0. So tan square theta equals to 0, right? From what we have there, that means tan theta equals to 0. So from what we have here, that means tan theta equals to 0. Now, I believe we have talked a bit on angle of any magnitude. So guys, if you have tan theta equals to 0, your theta is going to be equals to what? Your theta is going to be equals to what? What's your theta going to be equals to? What's arctan 0? Everybody, what's arctan 0? Do we have anybody with a calculator there? What's arctan 0? Anyway, if you go on to use your calculator, you should get your theta to be 0 and 180 degree right here. Okay, so if you go on to say that tan 0 is 0, then don't forget the third quadrant where you don't have tan as negative. The third quadrant said the rule for the third quadrant is theta. I'm sure we know all this. We've done all this in previous studies. The third quadrant said theta plus 180. So when we have theta plus 180, that will be 0 plus 180, which will give me this 2. So I'm sure we all agree with this. Yeah, arctan 0 is 0. So you all agree with this. This is based on angle of any magnitude. Don't forget, we're told that your theta was ranging between 360 and 0. So we have to use angle of any magnitude. So that's about that one. Let's try and solve for this one. So we have, in this case now, we have 2 sine theta is equals to minus 1. Then we have sine theta equals to minus 1 over 2. So we have sine theta being equals to minus 0.5. Now, angle of any magnitude must apply here also. So in angle of any magnitude, in this case now, you can see that your sine is actually negative. So you have to go ask yourself, where is sine negative? Sine is negative in the third and fourth. So in the third quadrant, but what is theta? You need to go on to first find arc sine 0.5. What's arc sine 0.5? Guys, what's arc sine 0.5? This is just revision of angle of any magnitude. I believe everybody or majority of people right here understand it. But if you don't understand, you can go back to our video on, you can just go on to check our videos on trigonometry. We have already explained that. So arc sine 0.5 is actually 30. So we have theta being 30, but don't forget, this 30 is not what you're going to use as your final answer. Your final answer will come from where was theta negative, which is the third and the fourth. So in that case, we're dealing with theta plus 180, which will be 30 plus 180, which will be what? 210. And then we also have the other one, which is 360 minus theta. And here we have theta as 30, so that will be 360 minus 30. That will be 330. All right? So that's that about that. Now, the two answers we have here for our theta is obviously 210 and 330. So we have gotten theta being equals to 0, theta being equals to 180, theta being equals to 210, theta being equals to 330. So let's go for this last one and see what we're going to find for this last one. So for this last one, we have sine theta being equals to minus 1. Our theta here will be equals to, what is arc sine minus 1? What is arc sine minus 1? Anybody with a calculator there, what is arc sine minus 1? 90 bar. Good. So arc sine minus 1, arc sine 1 rather, you don't, I told you already, you ignore the negative sign. So we have 90 there. So, and theta is negative in the third and the fourth. All right. Okay, let me do that somewhere much clearer because of some people may not yet. Just for the people that want to follow. So theta is negative on the third and fourth. So we go on to solve for the third quadrant. Third quadrant said theta plus 180. And your theta was 90. That's 90 plus 180. That's 270. All right. And for the fourth quadrant, we have 360 minus theta. That's 360 minus 90. That'll be what? 270. So obviously the two values you got here is 270 and 270. Now, let me tell you why this will never be part of the answer. So this will never be part of the answer because you can see we have tan theta featured here. Go on to press tan 270. It's actually undefined. So we will not be including this answer as part of our answer because theta being equals to 270 will make it's more like saying we're looking for values of just look at it this way, guys. We are looking for values of theta that when we placed into this equation we're going to have 0. So we said if you place theta as 0 into all this place and fill them in, you will get 0. That's the meaning of all this. If you put theta as 180, you get 0. If you put theta as 210, you get 0. If you put theta as 330, you get 0. If you go on to put theta as 270 here, once you place this in the place, remember the initial algebraic equation. Of course, this was the solution we have already gotten. But if you go back to our initial equation, if you go back to fill in theta as 270 there, which you can see tan theta was featured there, not even in one place, in two places. I'm sure you remember the original equation had plus tan square theta. Once you fill in tan square theta there, you'll be getting an undefined answer. Guys, can you follow what I'm saying exactly? This is why you cannot have 270 as one of your answers because tan 270 is actually undefined. If you press tan 270 on the calculator, it gives you your answer as undefined. So that's the reason why we will not be featuring that in our answer. So please always be very careful of all this. So 270 is expunged out of our result set. All right. We have other questions, but I want to run into calculus because I want to I want to see if we can quickly rush into calculus. Although there are still questions that was before the calculus, but let's get into calculus quickly and see what we can do there. So we have a question. If you have, you can take the question now. What is the critical number of the function? This is the function I'll be giving you now. It's a very simple one. I'm sure you guys can throw the answers to me in like probably 2 seconds. The question said what's the critical number of the function? This is the function. 4 minus 2 over 3 x plus 1 over 2 x squared. So what is the critical number? That's the question. Anybody with an answer quickly? What's the critical number of this function? Anybody with an answer already? What's the critical number? Do we have an answer yet? Or do you have an understanding of this? Or are you confused? If though you have an idea of you are trying to solve this, you know what to do, please can you signify quickly? Okay, let me just solve this for you. A critical number occurs when the derivative of the function is equal to 0, or when the derivative of the function does not exist. So this is the point that makes you to get your critical number. This is the condition that makes you to get your critical number. So your critical number is gotten when your derivative is equal to 0 or when your derivative of your function does not exist. So on the basis of using when your derivative is equal to 0, so we have to go on to find the derivative of x, which I'm sure every one of you can solve. So we want to go on to find the derivative of x, which obviously will be d. So we're trying to differentiate the function. All right. So you go on to differentiate this function. I'm sure you understand the rule of differentiation. To differentiate this, you have to differentiate individually. So differentiating 4, you get what? You get 0. Differentiating -2/3, of course, you get -2/3. And differentiating this, this will turn to +1/2, and this will be 2x. All right. Then this 2 will obviously cancel this. So we'll be left with x -2/3 as our derivative of the function. Now, guys, I don't know your level of understanding of calculus, but we'll be having a class possibly this week or whenever we have it. Full-blown calculus, we want to start from the beginning and see how we go from there. So this is the derivative of your function. Now, and we said a critical number will exist when your derivative is equal to 0. So obviously, this was your derivative of the function. So f of x being equal to 0 implies that obviously we have x -2/3 being equal to 0, and this means your x here will be equal to 2/3. So the critical number is actually 2/3. All right. So let's go to another question, still on calculus. I want you to find the limit, because this is on limits. Please ensure you are taking very good notes. I want to see it. I'm very interested in seeing it. So evaluate this limit. Our t tending to 0, and we have 1 minus cos t. Now, just so you know, these questions are all questions from last year JUPEB. All right. So this is not this is last year JUPEB question. You can check it out. So this is one of the questions that came out last year. So how do you find this question? Evaluate this quickly. Can you solve it? Can you solve it quickly? Anybody with an answer already? Evaluate this limit. So I'm not just interested in the note. I'm interested in your understanding of every of the questions we're solving. All right, let me solve this quickly because I'm not yet very sure of your level of understanding calculus, and that's why we'll be having very great tutorials around calculus very soon. So this is the question you have. You are supposed to find the limit of 1 minus cos t over sine t with t tending to 0. All right. So the first thing you have to find, you have to check for the indeterminate form. You have to check for that. If you have the indeterminate form being equal to 0/0, obviously you'll be able to use the L'Hopital rule. I'm sure you people know the L'Hopital rule. I'm sure you've heard about that one. I'm sure that one is part of your part of something you have probably been exposed to. The L'Hopital rule. But before you can use the L'Hopital rule, you want to check for the indeterminate form. So how do you check for the indeterminate form? What you have to do is to put in t as 0 directly into what you have here. So you put this into the expansion. So you'll be having obviously 1 minus cos 0, because t being 0, over sine 0. All right. This will be cos 0 is actually 1. That will be 1 minus 1 over 0. 1 minus 1 is actually 0. So this will be 0/0. So, okay, since you have 0/0 as your indeterminate form, you can go on to use the L'Hopital rule, right? So let's now apply this rule we talk about. And how do you apply this rule? You have to differentiate the numerator and denominator separately. So you have to go on to differentiate both the numerator and the denominator. So I'm sure you guys are familiar with this. So let's say this is the numerator. The numerator is obviously 1 minus cos t. So let's go on to find the differential aspect of this. So we are finding d over dt of 1 minus cos t. Now, what do you get when you when you differentiate this 1 minus cos t? Of course, when you differentiate 1, you get 0. When you differentiate cos t, what do you get? Differentiating cos t gives you minus sine t. So what you have here, of course, these are things that you don't need to ask me how I got it, because these are all identities, and you have to cram those or find a way to know those identity. All right. So when you differentiate 1, you get 0. When you differentiate cos t, you get minus sine t. So obviously this will be sine t. All right. Now the denominator, you want to differentiate the denominator. The denominator is sine t. So if you do d over dt of sine t, what do you get there? Differentiating sine t will give you cos t. These things are not things that you have to ask somebody to explain. These are identities you have to just note. All right. So now you want to evaluate the limit of the new expression. What's going to be the new expression? The new expression will obviously now be limit of our t tending to 0 when we now have sine t over cos t. All right. Now, placing t being equal to 0 here will be sine 0 over cos 0. What is sine 0? Sine 0 is 0. Cos 0 is 1. The final answer is 0, because 0 over 1 is 0. So this is it, calculus. I'm sure you guys are enjoying it, right? So briefly, before we get into another question on calculus, I want to just throw this one. This one is on parabola, but it's something I just want you're just going to pick an option, because now we have e being greater than 1. I'm sure you are done with this. We're going to another question. This is not related at all. So this is eccentricity being greater than 1, eccentricity less than 1. This is eccentricity equals to 0, and this is eccentricity equals to 1. Which of these four represents the eccentricity of a parabola? Which of these four, you can just, okay, let me label it as A, B, C, D. This is A, B, C, D. Which of these, is it A, B, C, or D? Which of these represents the eccentricity of a parabola? Which of these represents, I need answers. Which of these represents the eccentricity of a parabola? Which of these represent the eccentricity of a parabola? I want to get answers. Okay, someone says D, someone says C, I have all the options in the chat box. Wow. Anyway, this is the correct one. D is the correct one. All right. And let me run to complex number, then we'll finish on one question on calculus. We have it's that's not the only that's not the end of the question, but we will have to just solve those two questions and call it a day. All right. So this is the question, and I want you to uh solve. If z is given as this question came out last year. Complex number. If z is given as 3 plus 5i, determine the imaginary part of z raised to the power of 3. Determine the imaginary part of z raised to the power of 3. Oh yeah, I want answers because we have done that today, so I want you to shoot great answers. Determine the imaginary part of z raised to the power of 3. Any answer yet? I actually don't expect you to. I don't expect you to spend time at all in solving this question because I already gave you something that would work very fast. So, okay, just to remind you because of time, when you have z raised to the power of 3, I told you that I gave you a different expression before this, but I also summarized it as this. What we have is this. That's why you need to note this. This was a question that came out last year. So imagine you had this, and it was an objective question, by the way. If you needed to, if you went on to be expanding this whole thing by using z cube to expand everything, you will actually be wasting so much of valuable time in the exam hall. And that's why I will always advise you to learn some of these quick formulas. So this is the formula where you're having z cube. And this is the real part. This is the imaginary part. So when I'm asked to find the imaginary part of z3, I'm only interested in this. So I want to go on to find 3a squared b minus b cubed. Whatever this gives me is going to be my answer. So my a here is obviously 3, and my b is 5. So I want to go on to have 3 times 3 squared times 5 minus 5 cubed. This will be 3 times 9 times 5 minus 125. This will be 135 minus 125. This will give me my final answer to be 10. And that's all. And you're good. So 10 is the answer. All right? 10. So this is how you solve questions very easily. So let's solve one last question. Okay, the question said you should find the differential equation, the y over the x equals to y tan x. This was the question. Yeah, with those of you arguing that this is the imaginary part, I, of course, 10i, you can put that there. That was just me So 10I is actually included. So can you find that? Can you solve this quickly? Anybody with an answer there? We want to find differential equation of the y over dx equals to y tan x. So this is what we want to solve. All right. Just to be very fast, when you want to solve this, what you need to do initially is to you want to rearrange this. You have the y over the x equals to y tan x. So what you want to do is to initially divide both. You want to bring in the y to one side and the x to the other side. So you want to divide both sides by y. Or let me just rather say multiply both sides by 1 over y, 1 over y. And also, when you do that, obviously you'll be getting 1 over y, the y over the x equals to tan x. So what you want to do after this is to multiply both sides by dx. So multiply both sides by dx. So this will obviously give you 1 over y, the y equals to tan x, then dx. So this is the first step. All right. So we want to have this is the first step, and then you want to go on now to integrate, because you are told to solve, so that means you are told to find the value of y. When you're trying to find the value of y here, you want to integrate both sides. So you go on to integrate. All right. So let me just put this right here because of time. So you're integrating both sides now, and in integrating, if you integrate 1 over y dy, what you're going to get will be the natural logarithm of y, the modulus of y. And if you go on to integrate tan x dx, what you'll be getting is the natural logarithm of the modulus of sec x. All right. So that means what you'll be having all in all, this whole thing, this particular equation will be, of course, bringing the integral value of this. So this will be ln y, that's that of this, being equals to that of this will be ln sec x. Let me put this more straight. So this is from here while we integrated, this is what we got. So right, but don't forget we'll be having a constant of integration being added. I'm sure you understand why. Let's call it C1. All right, let's call it C1. So after doing this now, you want to go on now to solve for y. So if you want to solve for y, one way you can get your y being isolated is by taking the exponential of both sides. So you exponentiate both sides to eliminate the natural logarithm. So to take out this natural logarithm, you just take the exponential of both sides. So you want to take the exponential of both sides. So this will be e raised to the power of ln y being equals to e raised to the power of ln sec x plus c1. I'm sure you can understand what I'm trying to write there. So what this produces will obviously be y being equals to e raised to power c1 multiplied by sec x. So we have to let this our would take this our e raised to power c1 to equals to, let's just take it to be a constant value. So we may use a different letter, but you understand what I'm just no, I'm naming mine c. So by doing this, you'll be able to arrive at y being equals to c multiplied by no more, sorry, you will no longer be having the modulus. That's one of the things this will do. So c sec x. So this is your final answer. So no problem. We would be stopping at this point. I just wanted to exhaust this. So guys, don't worry. We will be dealing with calculus much later. So guys, thank you very much for joining. I really know this is the price you have to just pay for success. So we'll keep doing this so that we can get the result we're looking for. So if there's any issue with all this, don't worry, we will have a time for calculus very much later or very soonest anyway. So thank you guys for joining. I'll see you tomorrow. Enjoy the night. Enjoy yourself. Take care of yourself. Bye bye.